In this Intact.design tutorial, you will learn how to import parts through Onshape, set up a simulation, including explanations of basic options and controls and quick scenarios, and analyze results. There are several ways to upload files for analysis on Intact. Today I will show you how to import a file from Onshape. Search legoman in Onshape's public documents. Open the model on the bottom here. Make a copy of the public part for your own use. You can change the name if you'd like. I'll just call it legoman. Once the file has opened, you can edit it, but I'm just going to move on to analysis. To activate Intact, click the plus sign in the bottom left section of the screen. Hover over Add Application and click Intact. This is the Intact main menu. You can import models and access other saved models here. To import the legoman, click on Import Model. Under Assemblies, click Classic legoman. It takes a little while for the model to be imported. Refresh after a few minutes. Once the file shows up in the model inventory, you can click on it to start simulating. The Simulation Inventory window shows past simulations. Since we haven't done any simulations for this model yet, let's start a new simulation. Let's quickly go over some navigation controls. In the bottom right corner, there's a coordinate system displayed. Notice that when I move the legoman, the coordinate system moves likewise. This is very useful when defining load directions. You can rotate the model freely by clicking the left mouse button while moving your mouse. Moving your mouse while clicking the right mouse button will translate the object in space. Lastly, scrolling up and down zooms in and out from the model. Now let's take a look at the simulation setup controls. Clicking back will delete any changes and take you back to the simulation inventory window. You can change the title so you can easily go back and review specific simulations. The next step is selecting the material. Use the pull-down menu to scroll through the many materials available. Ferrous and non-ferrous metals, as well as non-metals, including 3D and engineering plastics, are all available material types. Material properties can be found in the Intact.design documentation. For this example, we'll use ABS, a 3D printed plastic that is used to make Legos. If your file is an assembly, the Set Multiple Materials button will be available. This option allows you to set a different material for each part. All of the parts in the assembly are listed, and you can use the pull-down menus again to select materials. For this example, however, we'll set the entire assembly to be ABS. Click the back button to save your changes. Next, set the up direction, which defines how gravity will act. There are 6 possible directions to choose from, defined by the X, Y, and Z axes. Refer to your model in the coordinate system to choose the correct direction. Since we want the legoman to be standing, let's set the up direction to be +Y. Next, set the unit system for forces. Since the model is quite small, choose inch, pound, second. Under scenario type, there are 6 different quick scenarios and an advanced option. Let's look at the gravity option first. The black and white checkered floor defines where the restraints will be placed, and the force due to gravity is applied in the negative y direction. Like the gravity case, the squash scenario applies the restraints on the bottom faces. A downward force is applied to the topmost faces. The magnitude of the force can be changed using the slider. The squeeze scenario applies equal and opposite loads to 2 sides of the model. To change which faces are squeezed, use the force angle slider. Changing the force angle rotates the forces about the up direction you selected. You can also change the force magnitude by moving the second slider. The push scenario places restraints on the bottom and applies a force to a side face. You can change the force angle, much like what we did with the squeeze scenario. Again, the forces rotate about the y direction, the up direction in this case. Like always, you can change the force magnitude. The bend scenario applies moments to opposite sides of the model. As with bending a beam, one side is in tension while the other side is in compression. Changing the torque magnitude from positive to negative switches which side is compressed. The switch orientation box changes the sides to which the moments are applied. Lastly, the twist scenario applies a torque about the up direction axis of the model. Additionally, the bottom faces of the model are restrained. Changing the torque magnitude from positive to negative changes the twisting direction from clockwise to counterclockwise. Now that we've gone over the 6 scenarios, let's choose one to solve. Consider this scenario. Lego Indy and his friend are desperately trying to outrun the boulder. Indy barely gets away, but his friend Charlie is not so fortunate. The boulder rams into Charlie, pushing on his back. Let's model this scene with the push scenario on Intact. Select Push for the scenario type. Recall that the push scenario applies a load to the side while restraining the bottom. Move the force angle slider until the force is applied to the Lego man's back, which is at 270 degrees. To get exactly 270 degrees, use the up and down arrow buttons. You can move the model around to get a better view and ensure the force is applied correctly. We'll keep the force magnitude at 5 pounds. Click Simulate to run the simulation. It might take a while for the simulation to solve. Check back every so often or wait to receive an email. Once the simulation has completed, click on it to view the results. The View Results window has two tabs, Simulation Results and Scenario Details. The Simulation Results tab offers several options to explore displacements and stresses in the model. Choose the solution property you'd like to inspect. Since actual displacements can be quite small, you might have to check this box to apply a scaling factor. Use the Deform slider to exaggerate displacements to a visible level. Red denotes maximum values and blue denotes minimum values. Use the color scale in the upper right corner to get a sense of the color values. To get numerical results at a point, hold Shift and right-click on the model. You can copy the link in the box to share your results with colleagues. Press the green button to automatically create a short animation of your results that can be saved and shared. You can also explore other solution properties. Next, let's take a look at the Scenario Details tab. You can review the material you selected for each part. The loads are also listed on this tab. Check the bottom box to show loads and restraints on the model. The loads are shown with arrows. Recall that we placed the load on the back with the push scenario. Lastly, restraints are shown as black shaded areas. Thanks for watching. To learn more or sign up, visit Intact.design.